to Sibanye Zim DevConf 2023, the moment we have all been waiting for, and finally it is here and it is happening. My name is Sibonile Mtunzi, and I am a software engineer. My interest, software architecture and design, artificial intelligence and machine learning, philosophy and poetry. These are the things that I'm most interested in this world. My skills: C#, web development, Django, Python, and data analysis. So the following is going to be my topic, software architecture and design. When I was deciding which topic I should present about, I thought this was the best, because sometimes I feel like we don't really pay attention to our software architecture, but it holds a very, very significant impact in the future, present and future. So anyways, diving in, imagine building a house without a blueprint. One could wonder, what kind of house would that be? I don't know. Do you know? I wonder if we'll find out. And how does having a clear plan for how software works impact the final product's quality and usefulness? It's very, very interesting to try and figure out, is it very useful? How does it impact the final product? So anyways, the following is my outline. We'll look at the introduction first, understanding software architecture and design, benefits, case studies, best practices, and key consideration. And then after that, we'll conclude the presentation. All right, so the introduction. So welcome to the exploration. Welcome to the exploration of software architecture and design. Here we unveil how architecture streamlines development, while design excellency hinges on sustained efficiency in addressing customer needs. The goal in software architecture is to minimize the human resources required to build and maintain the required system. That's the goal, nothing else. That's the goal. And the measure of the design quality is simply the measure of the effort required to meet the needs of the customer. If that effort is low and stays low throughout the lifetime of the system, the design is good. If that effort grows, that with each release of the design, it means it's really bad. Sorry to break it to you guys, but that's the case. Let's move on forward and see what's up. So the crucial role of software architecture and design. Before I elaborate on that, maybe I should explain the differences between software architecture and design. Software architecture, it's like planning the layout and structure of a house. It decides where the rooms, the doors, the windows go. It's about the big picture, the decisions that shape how the whole system will work. Whereas software design, on the other hand, it's like decorating each room. You're going to have the house, choose the colors, the furniture, arranging everything to make it functional and beautiful. Design focuses on the detail that makes the software user-friendly and efficient. So the roles of these, it creates a blueprint. A blueprint is very important because it's connecting, organizing, simplifying software elements for effective development. And also it makes it work well. Software design, like puzzle assemble, ensures flexibility, reliability, and efficiency, allowing seamless adjustments and enhancements. It also helps plan for the future. Good architecture prepares software for changes and challenges. It helps the software grow without breaking, keeping it safe from problems, and helps the development team work together smoothly. Okay, and then after that, what are the benefits of an effective software architecture and design? The first is enhanced maintainability and scalability, followed by improved performance and efficiency, and then we have reduced development costs and time. I'll try to elaborate a bit on what I've just mentioned. When you find a software, when the more users you have, the more problems you probably start having problems. It becomes slower, it's not very responsive. It all comes down to the fact that probably the architecture of the software and the design is not very good. And the goal, like I said, is the performance doesn't change regardless of how many people are using your platform. It should not change. So that's why it's very, very important to get it right from the beginning. Okay, so let's move on to the next part, which is let's look at some of the key studies, real world success stories. We have Google. Google's innovation stems from its microservices architecture, transforming development and deployment. Instead of building a monolithic applications, Google adopted microservices, breaking down functionalities into smaller manageable services. For example, we have Gmail, Maps, and Google Cloud Platform. Each service, if you notice very well, operates independently, allowing rapid updates and scaling, which is a very, very good thing, you know. And also, the other thing, we look at Uber, for example. I think some of you have used Uber. If you have traveled, you have probably used it one way or the other. Uber's triumph is powered by their real-time data processing architecture. When the user seeks the ride, the system analyzes the location, user availability, and the traffic to match them swiftly. This robust setup ensures seamless navigation, accurate fare calculations, and smooth payments. With millions of people relying on Uber globally, this architecture's scalability and efficiency are pivotal, showcasing how technology does sometimes, right, let's say, always fuels modern global services, if I could put it that way. Okay, let's move to the next. And then we also do have the real world lessons from failures. It's a little bit sad to present about Nokia because I have always been a die-hard fan in the past, rather not currently, but I was a die-hard fan. But unfortunately, Nokia's architecture is not so good. Architecture and design, it's not so good because of failure to adapt. That was the downfall of Nokia. It's outdated architecture that hindered innovation, and Nokia's reluctance to embrace emerging trends led to its decline as well. As smartphones began to gain popularity, if you noticed, Nokia clung to its traditional approach, you know, overlooking the potential of touch screens and advances in operating systems. So this resistance prevented from staying competitive in a rapidly evolving market of software. And we also have MySpace, which I don't know if you guys have heard about it, but it used to be one of Facebook's competitors. MySpace, the problem was its downfall can be attributed to its lack of flexibility and inability to adapt to the changing user demands. Remember earlier I did mention that no matter the amount of people that are using your software or whatever application, it has to always adapt. A good software always adapts to the user demands. So because of that, MySpace lost against Facebook. and it became very, very unpopular. And we can say the story underscores the importance of staying flexible, continuously updating offerings and listening to your users in the rapidly changing landscape of technology and social media. All right, so next, the best practices and key considerations. So it's very, very important to plan for the future. Whenever you're building any product, it's very, very important to plan for the future. The importance of long-term goals in the architecture and design decision, flexibility to accommodate growth, modularity, and reusability. It's also very important because design patterns and modular components lead to maintainable code base. Design patterns like MVC, singleton, and factory create structured modular components. I will not really dive deep into it, but I'll just say MVP separates logic, improving maintainability. Singleton ensures one instance of a class, enhancing resource efficiency. Factory generates objects and boosting reusability. So the practices lead to adaptable, efficient, and easier to maintain code, reducing redundancy, promoting best practices in software. And the last part is collaboration and documentation. Clear communication among development teams. Documentation aids in maintaining the system maintaining the system and knowledge transfer. And lastly, the conclusion is programmers should focus on planning and designing the overall structure of the software before they start writing code. They should follow certain rules and guidelines to make sure the software architecture is well designed and efficient. This helps avoid problems later on and leads to better quality of software. And the second part is good software planning and design for making a project successful. Just like a solid foundation is key to building a strong house, a well thought out software structure is essential for creating a successful project. Thank you so much. Looking forward to getting some questions and hearing other presentations. Bye.